Okay, so for tangents, I'm going to kind of go through a little bit more quickly, simply because it's kind of the same thing that we did with sine and cosine. We're just repeating the whole process. Now, with our tangent ratio, I want you to give me the table, the 5 key points for graphing tangent. So we've got, remember we do 0 to pi to get our key points. So we've got 0, pi over 4, pi over 2, 3 pi over 4, and pi. And our output values for those are 0, 1, undefined, -1, and 0. I'm going to plot those points. First thing, though, I want you to look at is your asymptote at pi over 2. And since this is the parent function, all of our asymptotes are going to be at our pi over 2's because they separate our tangent curves into individual cycles. Okay? And then when I plot the rest of these points here, my first one is at the origin. It's at 0, 0. My second one is at pi over 4, 1. Skip the asymptote. 3 pi over 4, go down to -1. And then pi, 0. Now, if you look back, I'll zoom in. If you look back within this cycle range right here, from the x-axis, we went up. That's what you're going to do right here. X-axis, you're going to go up and plot a point. And then this one, you know, going backwards, we went down. So over here, going backwards, you're going down. Now we have 2 completed cycles for our tangent curves. And in looking at this, to determine what we need to do to restrict the domain so that our inverse is a tangent, because right now, horizontally, you know, we're not going to, we know when we invert it, it's not going to pass that vertical line test. We've got x values that will have multiple different output values. So we've got to be sure that we restrict this. And just like sine and cosine, we always want to keep our first quadrant. So from 0 to pi over 2 right here. Okay? And just like sine, to stay connected, to be able to do the entire, like our entire range, we're going to restrict it back here to the negative quadrant. We don't want to skip over the asymptote and do this piece, skip the asymptote and do this piece. We're going to keep it one fluid section. So just like sine, we're going to restrict it from negative pi over 2 to positive pi over 2. And when we graph our inverse, let's go ahead and take our table and flip our x's and our y's. Notice undefined is now going to be an input value. And whenever we had undefined, we had an asymptote. That asymptote's still going to exist, but instead of being a vertical asymptote like what we have right here, it's going to be a horizontal asymptote at pi over 2. So we've got a horizontal asymptote at pi over 2. We'll have another one at 3 pi over 2, at negative pi over 2, and at negative 3 pi over 2. We have all of these horizontal asymptotes at all of our pi over 2's. And to plot our points, we've got the point 0, 0. So right here at our origin. Then we're going to 1 and up to pi over 4. Undefined. Then we go to -1 and up to 3 pi over 4. 0 and pi. Okay? So we've got two different little groupings that we started, but let's go ahead and complete that. And let's go back up to 1, and this would be 5 pi over 4. And we've got that tangent curve finished. If we go to -1 and negative pi over 4, we'll have that tangent curve finished. And what I want you to identify is how in tangent our domain, or not, I'm sorry, not our domain, our range was infinite. But when we did the inverse, our domain is now going to be infinite. Our range is not. Okay, we're going to have our limits. So take a look over here at your unit circle. Since we had to restrict our tangent function to negative pi over 2 and positive pi over 2, so that our inverse would be a function, we're going to show that on the unit circle. So we've got 0. Up here we've got pi over 2. And down here we're at negative pi over 2. When we head towards negative pi over 2, that's negative quadrant 1. And as we head to pi over 2, that's positive quadrant 1. And we're only allowed to use these two quadrants when we're dealing with the inverse. There's our positive ratios, there's our negative ratios. Okay, if you will flip this page over, I want to do something on the back, because something that was confusing, and there's a question on your assignment. When this talks about your inverse cosine and your inverse sine and your inverse tangent, your domain and range, this is what we restricted our original parent functions. If I'm asking for the domain and range for the inverse, an inverse function, you have to flip the x and the y. So I want to show you exactly what that looks like. Here's your parent, domain, and range. So you've got y equals the sine of x, y equals the cosine of x, and y equals the tangent of x. Okay, now I had to restrict my domain and range. Let's write that word restrictions here. I had to restrict my sine domain to only be from negative pi over 2 to positive pi over 2 in order for my inverse to be a function. And within that domain, my lowest point was a -1, and my highest point was a +1. So these were my domain and range restrictions for sine. For cosine, I had to restrict my domain from 0 to pi. That's the only part I could graph so that my inverse was a function. And my range for that was also -1 to 1. allowed me all possible values in my range. Now my tangent domain, I restricted between negative pi over 2 and positive pi over 2, just like sine. But notice the difference. Why do I have parentheses around tangent? Because of the asymptotes. Exactly right. And then my range, what was my range? Yeah, negative infinity to positive infinity. Okay, so those are my restrictions. So now, when I graph my inverse functions, y equals inverse sine, okay, of x. My domain is my range of my original. Because remember, to graph an inverse, you flip the x and the y. You just interchange them and graph it, and it will reflect across the graph of y equals x. So now my domain for my inverse is negative 1 to positive 1, and my range is negative pi over 2 to positive pi over 2. Those are my outputs. Because when you're doing the inverse, you're looking for the angle. That's what you're trying to find. So the angle is going to be the output. If y is equal to the inverse of cosine, my domain for this one is still negative 1 to positive 1, just like the sine. But my range for my angles is from 0 to pi because of what I restricted, so that my inverse would remain a function. And for inverse tangent, the domain, is our domain restricted? Because our range was negative infinity to positive infinity. So guess what? Our domain is negative infinity to positive infinity. Because when you look at the graph, we're going infinitely backwards and infinitely forward. So our x values are getting bigger and bigger and smaller and smaller. But our range values remain, parenthesis, negative pi over 2 to positive pi over 2. So there is a difference between the parent function and its inverse. To get the inverse, we have to restrict the parent. Okay? So, did everybody get this copy down? Was it? All right. So now then, let's look on page 13. We're going to do some more practice problems just of your inverse, okay? So now, if we have a positive tangent ratio, we're going to get our angles from quadrant 1. And if we have a negative tangent ratio, we're going to get our angle from negative quadrant 1. And just like sine and cosine, inverse tangent and arctangent mean the same thing. They are one of the same things. All right. Look at number 5 down here. It says inverse tangent for negative root 3. So obviously, which quadrant are we going to be looking at since it's negative? Negative quadrant 1. Okay, now, here's the thing. Which angle has a trig ratio of root 3? Has a tangent ratio of root 3? Huh? Not 30 degrees. 60 degrees, which is pi over 3. So since the tangent of pi over 3 is root 3, the tangent of negative pi over 3 is negative root 3. And let's look over here at the arc cotangent. Okay? The arc cotangent. Let's change this from, first of all, from arc to inverse. And let's change it from cotangent to tangent. So we've got inverse tangent. So since I changed this trig function, I better do my reciprocal over here. So that's going to be a negative root 3 over 1. Well, guess what? There you go. It's the exact same question as number 5. So our answer is going to be negative pi over 3. Okay. Now, yesterday, did we do any problems back here on page 14? Did we do any of these? We did. Okay, I'm going to pause this for just a second.